Good afternoon, everyone. This is Biplab from IIT Guwahati. You are welcome to the live session of this NPTEL course on data analysis for biologists. You can join this live session either through YouTube or you can join through the Teams link that has been provided to you. In the both cases, you can interact with me during this 1 hour session. Either when you are in the if you are watching it through YouTube, you can post your queries through the chat window, or if you are here in the Teams, you can also post on the chat. And if you want to ask any other, talk, you can raise your hand. You can ask me questions, right? So I am the instructor of this course. We are already in the 4th week of this course. So what I will do today in this 1 hour session is that I will brief the key issues that we are dealing in this course. I should mention those points which should be highlighted, which you should pay more attention to when you are studying. I will also provide you logistics information about this course, and also discuss how you should prepare for the final examination if you are registered for that. If you haven't yet registered for the final examination, please register for the final examination because the window is still open and many of your friends have already registered for the final examination. So I will encourage you to register for the final examination. Anyway, you are doing the course and registering for the final examination and getting a certification will not require you additional efforts, but eventually you will get a certificate that you have completed the course successfully. And that may be useful in your further journey, academic and other journeys. So I will strongly encourage everyone who has registered for this course also register for the final examination. Now let us come down to the course content and what you should focus on. So this is a 8-week course. So 4 weeks is almost done. So I will discuss about this 4 weeks content. And in the next live session, I'll discuss the other 4 weeks content. Now, you must have noticed this, how the syllabus has been arranged, right? So the syllabus has been focused primarily on what nowadays people call machine learning. Although nowhere in our course we are saying that this is a machine learning course, but if you have seen the content, you must have realized this course does not focus on the classical data analysis like classical biostatistics. No. There are courses on biostatistics on NPTEL. If you have not done that, you should go for that. You should do a biostatistics course. But as we know that the data analysis of biological data has crossed the age of pure biostatistics, and now you have different machine learning techniques. Those are used widely in day-to-day work of experimental biology. Whether you are coming from molecular biology, cell biology, you are doing epidemiological studies, or you are doing ecological studies, everywhere you have to use statistics, you have to use machine learning techniques, you have to use regressions. So this course focuses primarily on machine learning techniques like building linear, nonlinear model through regression. Then we go for clustering and classification, and then we go for how the techniques to handle higher dimensional data. Because you know that nowadays we are generating a huge amount of data through high throughput experiments like single cell RNA-seq and other things, where you have a very large dimension, very high dimensional data, and conventional statistical technique will not allow you to handle that type of data. So in this course, we learned in the last week how to handle the higher dimensional data. Now, I will go through the key points that you have to focus on in the week 1, week 2, week 3, and week 4. But before that, let me give you some information. This is as a course instructor, this is my live session, and hopefully we may have another live session somewhere in the fag end of this course. It's an 8-week course. Apart from that, every week, one of our PMRF TA is actually organizing a live session, which is a problem solving session. The link to join that is already in the announcement section of this course. So please, every week she is live organizing a live session. Attend that. In that session, she goes through the essential concept of that week's lectures. She discusses how to solve problem. I provide her some mock questions which she solves in the live session. So you should be able to learn from those solutions. And also you can ask her question and clear your doubt. So I will insist, please join these live sessions, right? These live sessions are also recorded and eventually uploaded in YouTube. That link are also provided in the course portal. So you can always see those live sessions later on. But remember, it is always good to join a live session live, because then immediately you can clear your doubts and interact with us. So please join this live session. Many students are joining and many are not skipping it. But believe me, these live sessions, which we call problem solving live sessions, are extremely useful. So please join them. And all the details about those live sessions, how to join, where you can go get the recorded live sessions in the YouTube, and the schedule of those live sessions, everything is available on the course portal in the announcement page, as well as there is a separate tab where you can go and get an Excel sheet where all this detailed information is there. So I must insist that please join this. Okay. If any one of you has joined late, just to remind you, if you have any query, you can post the question here in the chat in the Teams or in the YouTube chat window. Now let me go to one by one through logistical issues about this course, how you should prepare for the final exam, and eventually the key point, key concept that you should focus in this course, in this 4-week content. So the first thing is, see, apart from the background theory of these machine learning and model building technique and data analytic technique that we discuss in this course, we are also teaching you how to use R to perform this analysis. R is an industry standard across the globe. In academia as well as in the industry, large-scale data analysis are done using the R language. In fact, R has been developed ground up for large-scale data analysis and statistical analysis. So it is not just biology people. People from across the globe, from different fields of science and technology and business, use R. And if you know that, if R skills are in your profile, then eventually your profile gets extra weightage. And in day-to-day activity of research and business, it helps a lot for data analysis. So for this course and in general, I will insist, please learn R. Now you can say how much R I have to know. See, eventually any programming language, you cannot expect to become master of that language in 1 year or 2 years. Even people who are using R for 5 years, 6 years, they cannot vouch that they know everything about R. You cannot learn a language like that. We learn by using it. Every day when we use it, we learn it slowly. So that will happen with you also. We are taking baby steps in the course. We are slowly moving step by step. We are not teaching everything involved in R, right? But whatever we are teaching will help you to push through and learn further. And obviously, what we are teaching, the videos on R in this course are sufficient to cover up this course. Now, I know many of you have never done programming, right? Many of you have not done programming, and you may find it daunting to start. But remember, somewhere you have to start. So this is your best opportunity to start programming, and please learn R with us. Learn whatever we are teaching. That little amount, if you can learn, you can eventually will be able to learn further. It's just like learning any other language. Once you start and you start practicing every day, you start using a language every day, eventually you get a grip on that. That's what will happen with you also. So do not get bothered that you never have learned R or any other programming languages, so you will not be able to do that. Now, one thing, how do you practice? If you go to the course portal, in any lecture, if there is a R code, that script and the data files, all links are provided. Apart from that, all these R codes, R scripts, as well as the data files are available through my GitHub page. You can actually download it. So I'll hold it here for some time. If you want to note, you can note it down, or you can go in GitHub, search with my name Biplab Bose. My repository will come. In one of the repository in my account is this data analysis for biologists repository, and you will be able to download all the R script that has been used in this course along with the data file that we have used. This link is also available in the question answer forum for this course, so you can go and download from there also. Now remember one thing, learning a language is best when you take a ready-made code and break it, make a new code out of it. So I will insist, please download this code, play with them, edit them, and see how when you edit something, how things get changed. For example, suppose we are teaching how to create a scatter plot. So there will be many arguments that you have to use for the plot function to create a scatter plot. So why don't you download the code and manipulate, change those arguments with different values as per your wish and see how the diagram changes. Then only you will be able to learn how to use that language. Now, one important thing many people has asked me over the mail is that whether we should be using R in the final exam. Now remember, in the final exam, it is a computer-based exam, just like GATE and JEE. So in that case, you will not be able to access R. So that means you will not do any live problem solving using R in the final exam. But there will be possibly question based on R. For example, if you look into the assignment of week 3 or week 4, you will realize that we are asking question based upon the R language. For example, we may ask, okay, here is a function lm. We will learn this. This will be used for linear regression in future, in I think 1 or 2 weeks. Subsequently, you will learn linear regression, and you will use this lm function of R to perform linear regression. Now, in exam, we may ask, what is the purpose of lm function? Something like that, right? So you have to prepare for exam, and in that there will be R-based questions. So although you will not run a R code, you should know how to write a R script or R code, and you know the meaning of those functions, syntax, all these things. So please learn R with us in this course. Another logistical issue that you should remember, if you have registered for the final examination, you cannot carry any calculator, but this is a math-based course. So there will be mathematical problem which you will have to solve numerically, right? So there is a software, the exam software. You must have be acquainted in GATE and other exams. You use that, right? You will have an online scientific calculator in that tool. You will use that. Fine. So that's all in the logistical issues. So now what I will do, is there any query up to this from anyone? You can ask here in the YouTube chat window or here in the Teams. I'll pause for a few minutes. Okay, so if there is no question, let me go to the important concept that you should focus while going through the course. Week 1, week 2, week 3 are almost over. Week 4, we are in the week 4. But specifically, I'll again go through week 1 and week 2, week 3, 4 concepts, which are key concepts that you have to learn, right? So if you go to week 1, remember in week 1, we are teaching you the elementary concepts of probability theory. Many a time, students think, why should I have to learn probability theory, right? Particularly if somebody has not studied math for long, they may wonder why we have to learn probability theory. Remember that any statistical analysis is based on probability theory. So if you want to learn how a statistical technique works, you have to know what is the background aspects of the probability theory. So without probability theory, you will not be able to understand how a particular statistical technique works and how to make a meaning out of it. So that's why we insist that at least the basic level of probability theory one person should know. Second point, the machine learning world, the world of machine learning, as well as the world of AI and artificial intelligence rely heavily on certain aspects of mathematics. One of them is probability theory. And the second one is linear algebra. And as we move into subsequent topics like linear regression, polynomial regression, the dimension reduction, you will see how much we use linear algebra. So if you do not understand the basic content of those, you will be clueless. You will not be able to understand why somebody is treating the data in a particular fashion. That way, it is actually meaningless. If you want to use a technique blindly, then the most possible chance is that you will be using it in a wrong way. You will be misusing it, right? So to avoid misuse and to understand what your data analysis is actually telling, you should know some amount of basic concept of probability theory as well as linear algebra. And that is why in the week 1, we discuss probability theory, and week 2, we discuss the linear algebra part. So in the probability theory, I do not expect that you will learn everything about the probability theory. But the certain thing which you have to know so that you can appreciate what we are learning is that you have to know the basic rules of probability, right? For example, that if A and B, two things can happen, then probability of A plus probability of B will be equal to 1 if they are mutually exclusive. So this idea of mutually exclusive, independent, the sum of the probability should be equal to 1, probability should be less than or equal to 1, these basic rules of probability, right? And then the rules of addition and multiplication in case of exclusive and the independent event. These things are elementary, but remember, these are used almost every time you do some sort of data analysis. So you should understand and learn those. Second thing is you should understand the difference between PMF and PDF. Just to remind you, PMF is used when you have discrete random variable, right? Whereas the PDF will be used when you have a continuous variable, right? So in these two cases, there is a difference. In case of a discrete random variable, you have probability mass function, which can give you the probability exact value, where the PDF is just a function which you integrate or you take the area under the curve to get a probability, right? So these issues, it should be clear to you. And then you should know some of the PMM and PDF should be in your mind. Not all. There may be hundreds of PDF and PMMs which are very well characterized. If you pick up a probability theory book, you'll get confused. You have so many things. You don't need all these things for our course. Just learn what is binomial, what is multinomial, and Poisson. We have discussed these three in the course. And then normal standard distribution, these two, and uniform and exponential. I will insist that please at least learn and understand what is normal and standard normal distribution, because these will be used again and again in any course of statistics and machine learning and our course also. And then the concept of mean, variance, their formula, how to calculate means and variance, how to calculate covariance, how to do the Bessel's correction, which are you have to apply almost every day. right? This Bessel correction is something which is very essential, but what I find most of the students, even the researcher, they forget to use that. Right. So if you have a small number of data, for example, your sample size is 3, 4, 5, like that. Suppose you are measuring gene expression in 5 tissue samples only, and you are actually taking the mean of those and the variance in that. In that case, you have to use Bessel's correction. You cannot just simply use the ready-made function in Excel or somewhere. By the way, Excel has now a function to use Bessel correction, right? But earlier it was not there. So people used to use blindly calculate the variance, and that variance is not the right calculation. You are supposed to use Bessel correction in this case. So these things you have to learn, because this is elementary thing which will be used day and night, any quantitative study you do. Not just biology, any quantitative study you are doing, you will be using calculating mean, variance, and covariances. So you should know how to calculate them, how to correct them, and why to correct them. That is the most important, that why I'm correcting, right? So this we have to know. And then the idea of conditional probability and marginal probability are important, because they eventually leads us to the Bayes theorem, right? Bayes theorem. And I don't know whether you know it or not, Bayes theorem is now everywhere in biology. You want to analyze your large-scale gene expression data, you have Bayesian inference models. You are analyzing image analysis data of cell images, MRI images, you have Bayes models. So everywhere you go, Bayes theorem will pop up. So you may not go in details of all those algorithms, but you should know what they're talking of. What is Bayes theorem? How they're applying it, right? So that's why in this course, we introduce you to Bayes theorem. It's not very difficult to understand. Once you understand what is conditional probability, what is marginal probability, and then if you look into Bayes theorem, the theorem is very simple, extremely simple. Now, only thing is that you have to appreciate its use. One use is obviously to use that to calculate the predictive power of a assay like ELISA or some other diagnostic test that we have discussed in the class, right? There are many hundreds of other uses of Bayes theorem. So in all these cases, the Bayes theorem will be used. I have discussed only the question which is very common in biology textbook, and in exams and quizzes interview people ask, that if you know the sensitivity, specificity of a disease and or something like that, so how you will calculate the how good a particular assay is, and that's what we have discussed in the course. And while doing that, please pay focus on what is sensitivity and specificity, right? So true negative rate, true positive rate. These two things are very common in quizzes, exams, and interviews. Very common. Like if you go in an interview where they are asking you data analysis or statistics-based question, you can always expect that somebody will ask you the question, what is sensitivity, what is true positive rate, and you should be able to tell that, right? So please pay focus on this. And finally, we touch a bit of test of hypothesis. Intentionally, we have not discussed in details of these test of hypothesis like ANOVA, chi-square test, all these things we have not discussed, because those are part of classical biostatistics and there are good courses on that. I will insist, please go do that. In detail, you learn about them. Here I have touched upon because in many cases, for example, in the coming week when you will do linear regression, you will be using t-test. So some amount of idea what we are doing there, you must have. So just to introduce you, if you have forgotten or you have never studied what is the test of hypothesis, we have discussed that in the last and the fag end of the first week. Fine. So these are the key points that I have jotted down here, listed here. And if you are, irrespective of whether you are preparing for the final exam or not, please focus on this, right? So is there any query on week 1? Okay, If there is no query on week 1, now then let me move to week 2. As I said, in week 2, we are dealing with linear algebra, right? Any data set you collect in exam experiments, right? How do you store usually? Most students I see, usually, we will store it in Excel format. Yeah, that's quite obvious because most of us are using Windows, right? Or any other, some sort of what we call spreadsheets, right? So you have columns, you have rows, right? In the course, I have insisted when I'm teaching R, if you look into the R initial R videos where R has been introduced, I have asked to store the data in that type of format, but not in Excel, but in a tab delimited or CSV format in a plain text, so that any software you use can open it. For example, if you store your data in Excel, then if I am not using a Microsoft Excel in my machine, I'll not be able to open it. But if you can send me a CSV file, possibly I'll be able to open it in some other software. Now, whatever it is, whether it's a CSV file or an Excel sheet, you have columns and rows. The easiest way to imagine it is actually a matrix. And each column will be a vector. Also, each row will be a vector. And then if you understand what is vector and matrix, then transforming this data become very easy, because then we can use the idea of linear algebra. Many programming languages like R, Python, MATLAB, they have very strong packages of linear algebra. So we can manipulate, transform this data. All these things we can do very easily if I can consider my data set either as a vector or as a matrix. So that's why in the first week, second week, we are learning how to represent data as vectors and matrices. And then once you represent the data as vector and matrices, then you can start doing some elementary basic calculations like addition, multiplication, dot product, all these things. So these things are discussed in the second week. Some of you may say that you may not have done math for long. It does not matter. Please systematically try to follow the lecture videos of the second week course. You do not need additional math book, any other material to understand what we are teaching in linear algebra to you. Do not skip the videos. If you skip 1 to 5, first few video and jump to the 5th one, you will be in trouble. So go step by step, right? Learn what is a vector, basic concept, what is a matrix. Then once you understand what is a vector, how to do these basic calculations like dot product, addition, multiplication, like that, the idea of unit vector, orthogonal vector, you go through them. And then you learn matrices. Again, do not go into matrix without learning the vector, right? Once you have learned what is matrix, what is a diagonal matrix, what is a null matrix, what is the identity matrix, what do we mean by a symmetric matrix? Symmetric matrix will come up very frequently in the upcoming weeks, right? What do we mean by that symmetric matrix? What are the properties of symmetric matrix? All this has been discussed in these lectures. Don't skip them. Go slow. If you have never studied linear algebra, don't get bothered. Go slow, repeatedly listen to it. And as I said, you do not need any additional textbook or material to learn this topic. You can learn this through this video only. These are self-sufficient. And then once you are confident about the matrix, look into the matrix operation, how to add two matrices, how to multiply one vector with matrix, right? You do that, how to do a transpose, what is the determinant. Now remember, some calculations like determinant, inverse, eigenvalue, eigenvector, they are difficult to do manually. And in reality, in this course also, and in real life, when you will do data analysis, you will not calculate an eigenvalue of your data matrix by manually. R has a function. We are teaching you that in fact, in a video, in a lecture, there is a video lecture. I have shown how to calculate eigenvalue, eigenvector of a matrix. So you'll simply use that function of R. But you need to know what is the eigenvalue, eigenvector, and definitions are sometimes obscure. So if you do your calculation by paper and pen by your hand, then things get clear. But as I said, it is usually difficult. Many calculations are difficult. But for 2 by 2 matrix, like a matrix like this, 1, 2, 4, 5. If this type of two-dimensional matrix, right, this is 2 by 2, 2 row, 2 column. For this type of matrix, you can easily calculate inverse manually. You can easily calculate determinant, right? Eigenvalue, eigenvector, you don't need, right? But you can use R. There are online tools also to calculate. So what I'm saying is that please do not get bothered about details of complicated calculation. Create a small, simple 2 by 2 matrix and try to do addition, multiplication, transport, determinant, inverse. These are doable, very easily doable. If you can do it for 2 by 2, then you will not do it for a 20 by 20 matrix, definitely. Nobody do it by hand. Everybody will use R or some other language, other programs, right? So you will also do that. But you will be confident that what the program is actually doing. You will be understanding it much better. And then we discussed about linear equations, how system of equation, how to represent that matrix and vector format. Then one important idea that we discussed there is the idea of linear independence, right? So I have a matrix with columns. When can I say these columns are linearly independent, right? This idea, because remember these columns may represent different variables that you have measured. Suppose X, Y, Z, blood pressure, systolic, diastolic, and the age. Suppose these 3 variables you have measured in patients, right? So are these 3 variables linearly independent or not? If they are not linearly independent, then you have trouble. Many of your calculations go wrong. So when we apply certain technique, we need to understand whether the variable that we are measuring and then eventually using in our data analysis, are those variables linearly independent? Right? So this idea of linear independence is very critical, and you should understand that. In the lectures we have explained it. Please try to understand that. The last lecture in week 2 is about singular value decomposition. Some of you may not have found this particular topic very easy to understand. Some of you must have found it very difficult to follow. No problem. Even if you do not understand SVD properly, that lecture, that is not going to harm you. SVD I have incorporated because you should know at least that SVD exists and what SVD does, because SVD works under the hood in many algorithms. So if you go for an interview and you say that I know machine learning technique like dimension reduction and all these things, right? I can do PCA. And then people start asking you intricate question to check your capabilities. And then they ask, okay, do you know what is SVD? If you say, I have never heard of it, then you are in trouble, all right? So SVD is a technique which is widely used in many algorithms of data analysis and machine learning. So at least you should know what it is, right? That's why I have incorporated that as the last lecture of week 2. If you find it very difficult to understand, do not get panicked. You do not need to understand everything of the math there. If you understand, that's fair and good. Excellent, right? It will help you a lot. But even if you do not follow everything, do not get bothered, do not get scared, do not get disheartened. If you can simply understand what SBD is essentially doing and what is the full form of SBD, that will also help you a lot. Fine. So this is the key points for second week's content. If somebody has any question on second week's content or any other query if you have about the course, you can ask on the chat windows, either on YouTube or in here on the, the Teams. So please go ahead. I'll pause for a few minutes.
Thank you, sir.
So if there is no more questions about this week 2, let me go into week 3 contents and highlight. Give me a minute. Okay. Week 3 and week 4 of this course is dedicated to jumpstart programming in R, right? So we understand that many of you may not have done any programming at all ever. So you need to understand how a program works, you need to understand the basic syntaxes and then move forward. That's why week 3 is focused on that. There we are learning the bare minimum essential syntax, essential functions, and the essential tools that you require to perform certain data analysis, certain machine learning techniques use, all these things in the subsequent week. As I said at the very beginning of this live session, nobody can vouch they know R completely, not just R. Many of us use different programming languages. We cannot vouch that we know everything. I started learning C during my undergraduate days, right? The C course. I kept on using C. Still we use C in our work. But that doesn't mean after these 20 years, 25 years, I cannot say I know everything about C. No, it is not possible to know everything about C for me. What I know, I can work on it, right? So the more you work, more you learn how to use it. If somewhere you have to start, as I said, R is the industry standard, you have to start it, some learning. So if you are novice, you start with the basic things, you learn the bare minimum thing that is required for this course. If you have programmed in other languages like Python, C or Fortran or any other language somewhere, then you will learn it R very easily because this is the issue of just syntax. Nothing more than that, right? The only syntax changes, right? Symbols will change, the way we write something will change, but the core concept will remain same. So those people who have done some amount of programming, it will be easy. So you can go ahead and learn beyond what I am teaching in this course. But for those who are learning new, please learn step by step what we are teaching in week 3 and then week 4. Don't jump lectures, one after another, right? And as I said, all these codes and data files are provided to you. Download those, edit them. The R will give error messages. Try to understand why the error message is coming and you will learn the language. I guarantee you will learn it. Do not get scared. Start today if you have not started already. I guarantee you will learn a lot, right? And you will be confident enough every day. So what you have to do, you have to get habituated with R. You have to, in the week 3, we are learning the basic operation like arithmetic operations, logical operation, how to read the right data, because it's the data analysis course. From your experiments, whether it's in a wet lab cell biology experiments, or it is coming from some epidemiological studies or ecological studies, fieldwork studies, you have data files, large data files in large number. You want to read them in and then do analysis, and then you want to save the outcome in another file, right? So reading, writing data is essential. So these are basic things you should learn, right? So you learn them in the third week in a very few lectures. Then we moved into this matrix and vector because, as I said, almost every technique of data analysis use linear algebra. So that means I have to convert my data into the right suitable vector and matrix format. Many a time you will find that your function is not working, your code is not working because you have not given the data in a right format. You may have given most of the time in R, we have data frame. But many functions that you will encounter in R, which will not take data frame, that will take only matrix. So I have to convert data frame to matrix. So all these elementary things you will learn in the week 3, how to handle matrix, how to create matrix, how to create vector, how to multiply, add, all these things. So you can consider the content related to matrix and vector in week 3 is just supplementing what you are learning in week 2 in linear algebra, right? So these 3 and 4 point, matrix and vector and handling matrix and vector are very critical. Is there anybody who is facing trouble in using R? You can tell me here. If you face any problem in using R, please post that on the discussion forum. Usually in discussion forum, we are very active. Within half a day or one day, we respond, right? Either me or the TA working for us will respond and your problem will be addressed, right? So please be active in discussion forum, post your problem there, and also look into what other people are posting so that you can learn something from them. Now, week 4 is interesting. See, the data analysis means essentially you want to make a meaning out of your data, right? Either you want to try to prove something, or you are trying to understand something, or you are trying to create a model. But many a time, visualization of data helps to communicate what you want to say. But most importantly, visualization data is usually the first step before you do all mathematical analysis of your data. Because remember, all of us are visual. In a way, we are good in visual things. When you just simply show me an Excel sheet, I will find difficult to take a meaning out of it. But if you show the graph and chart, then I can understand the data very easily. So usually anybody, even a seasoned data analytic person who is working in the industry for 10 years also, they don't look into the raw data file. They don't start creating a model or analysis or statistical analysis. They first try to plot the data in different way to get a feel about the data. What is there in the data? What type of variables are there? How those variables are possibly related? Once you visualize them, then you get a better feeling about what type of technique you will use, what type of statistical analysis you have to do, what type of regression you have to do. Do I have to do data clustering, or this is something else has to do? What type of clustering technique I may use? Which one will work, which will not work? All these things you may get clue once you visualize. So whenever possible, we must visualize the data before we jumpstart our analysis. And as I said, always visualization is used for science communications. So obviously you have to visualize your data for that purpose also. So in week 4, we are teaching how to visualize data using R. Now visualization can be in different way. You can have 100 different types of plots. I cannot teach them all in 1 week. Essentially, then we require a separate course on data visualization. And this is not a data visualization course. So what I have done in week 4, we are working on the essential visualization, like scatter plot, where you have data point like this, or you have some line plots, or you are drawing bar plots, or you are doing histograms. Like flow cytometry data, you will always plot in histogram. And then one interesting thing that we teach is box plot. And in one lecture, I discuss in details why box plot are better than bar plots. And you should avoid bar plot in certain cases because bar plots hides a lot of information. Box plot I have seen over the year, people find it difficult to understand. For example, it is very easy to understand the middle line in the box will be the median. That is fine. Most people understand that, right? But what is this whiskers? And then there can be outlier. What is the outlier? These are related to median, interquartile range. All these things we have discussed in a lecture in week 4. Please pay attention to that, right? And you should be able to answer questions related to that also. And then we go into discuss 2 things which are not very old. Old in the sense biostatistics is a very old field. T-test, ANOVA has been are using for ages, right? But there are certain techniques, certain mathematical technique and visualization techniques also has evolved in last 1 and 2 decades because we have new type of data, the high throughput data. One of them is heat map. The other one is volcano plot. So we have discussed in week 4. Another is to visualize data as networks. And if you are in biology, like molecular biology, doing, you must be aware about networks of genes, networks of protein, networks where proteins are connected to diseases, networks are used now to identify drug targets, everything, everywhere you have networks. And these networks can be directed, undirected. You can do lots of mathematics out of it also. Those we are not discussing, but we have shown the visualization of networks. And last two lectures are actually very interesting in this week 4. And in fact, again, this is something which we have discussed superficially because you may require almost 2-3 weeks course to understand what is called ggplot, grammar of graphic and ggplot2 package. ggplot2 package is a very powerful package. If you look into high-end journal papers like Nature, Science, and any other high-end journal paper where you see such beautiful graphs, right, with different types of colors and all these things, those are not done by run-the-mill programs. Most of them have been created using specialized packages like ggplot2, which has hundreds of options. Once you learn them, you can manipulate hundreds of things to show what you want to show, the way you want to show. So you get an enormous amount of freedom. As I said, I cannot teach ggplot2 in just 1 or 2 lectures. So we have superficially covered it. What we have tried to cover essentially the principle of grammar of graphics, how different elements are combined together to create a graph, and we use ggplot2 as one example, right? So if you are very interested in data visualization, as I know many students are very interested in data visualization, they have a keen sense of aesthetic, I will insist, please learn ggplot2. You will go a long way because this is also an industry standard and you can create very sophisticated plots which are not possible in ready-made tools like Sigma Plot or any other plotting software. So that's all for week 4. So what I have done till now, I have discussed week 1, week 2, week 3, week 4, the key concepts, key ideas, what we are discussing. If you have any query up to this, please ask me. Otherwise, we are moving towards the end of our session. Okay, it seems there is no more questions. So just to wrap up, if I can wrap up what we have discussed till now, is that I have discussed about the key concept that has been discussed in week 1, week 2, week 3, and week 4. As I said repeatedly, real to understand, perform well in this exam, and learn. Oh, please follow the lectures, videos slowly without skipping. That is good enough for you. And I can vouch, if you follow this instruction, you can do very well in the final exam also. Now here is another additional information for people who have registered for final examination. Please remember, your assignments marks are used in your final scores. So assignments are very important. They are important for 2 reasons. One, the marks goes from there also, as well as when you solve the assignment problem, you learn the subject and you can expect similar question in the final exam. So if you are doing good in assignment, obviously you will do good in the final exam also. And suppose in some assignment, you have not been able to perform well, or you haven't got time to submit the assignment or something, please go back and check the solution. What I mean that you should be able to solve the assignment problem once the solutions have been given and you have checked that. Because as I said, similar questions you may expect in the final exam, right? So you should be able to solve those problems, right? So once you solve a particular problem, you can imagine what other type of problem can come which are connected to that particular question. So you can, if you can solve one, you can solve hundreds of similar questions, right? So please practice those assignment problems. That is very important. These are important to learn the subject as well as to get a good score in the final examination also. As I said, we have live session. I'll come again possibly in another live session where you can meet and discuss about your queries. But apart from that, please attend this PMRF TA every week's live session, problem solving session, because there the TA discuss in details 9, 10 problems. She solves them live, so you can see how to solve them, how to numerically solve a problem, what is the logic behind it, and if you have any doubt, you can get clarified, right? So please join them. All the instruction of links and the schedule, YouTube video links, everything is provided on the portal announcements page, as well as there is a separate tab where you can get those information. And the last one, please be active on the question answer forum. Any question you have, any query you have, post it there. I understand that online learning is not easy. You have just registered, you have hundreds of other things to do in life. You may be studying somewhere, you may have a job. Out of those, you are taking out some time to do this course, and you are alone, just with watching these videos in a phone or a computer, right? That is not a good atmosphere to learn something. You are alone trying to learn something. So the best way is to post question, interact with us, and interact with other fellow students. So please be active on the discussion forum, which we call the QA forum, right? Post the questions there. Even if you do not have any question to ask, go back and check what other people are asking and what is our answer. As I said, we are active on the forum and we try to answer these your questions and queries within half a day or a day, right? So please be active there. So is there any questions? Because we are at the fag end of the session. Okay, we will wait for 2-3 minutes. If there is no more questions, then we'll go off.
Okay, sir. सेशन कंप्लीट हो गया सर.
Will complete. So as there is no more questions, then we can close the session today. Thank you for joining with me and happy learning. See you in the next live session. Thank you.
Thank you, sir.
Okay. Thank you. Just a minute, there is a, okay, I think that person, I don't know whether that person is there. There is a question, Shruti Devatia. Just a minute. I have just seen 2 lectures. Shall I apply for the exams? I will insist that please go through all the lectures and attend, appear for the exams, right? And regarding how much math is needed, all I have discussed. Hope the questions are clear to you. Thank you for joining. We can close the session now.